My name is Dr. Yeap Ban Har, and I will share a word problem with you. 105, or some of us will read this as 105. 105 people went on a trip. 4/5 of the adults and 2/3 of the children went on several vans, and the remaining 29 people went on a bus. The problem today is to come up with one or more questions, mathematical ones, that can be answered using the information I have given you. You have the option of using materials like this to build a model, or you can choose to simply draw the models, or you may choose to use calculation. It is entirely up to you. Talk to your friends about this word problem. Remember, when we solve a problem, we try to solve it in more than one way. Hopefully, you can get method 1 and method 2. And perhaps, on clever days, you might even get method 3. I wonder if today is a clever. Also remember, we agree to listen. We do not need to agree. Sometimes, when discussing things with our friends, we may have different opinions, different ideas, different solutions, different answers. That's all right. We agree to listen. We do not need to agree. Let us now try to solve the problem. Method 1. We can use guess and check. We can try to make a list of possible numbers that add up to 105. How many adults and how many children went on that trip? We know that they must add up to 105. What could the number of adults be? Could it be simply any whole number? No, because we know that 4/5 of the adults went on the vans. Can the number of adults be 10? Would 4/5 of 10 make sense? How about 15? How about 20? How about 21? You are right. The number of adults must be a multiple of 5. Likewise, what numbers are possible for number of children? Remember, 2/3 of them went on the vans. That is right. 3 is possible, 6 is possible, 9 is possible, so are 15, 18, 21, 24, and all the multiples of 3. Let's make a list and use that to help us solve the problem. Method 2. Bar models. Perhaps I can let this represent the number of adults who went on the trip. Why did I use 5 units? That's because 4/5 went on several vans, and the rest of the adults 1/5 of the adults went on the bus. And this is the model for the number of children who went on the trip. Why did I use 3 units? That's because 2/3 of them went on the vans and 1/3 of them went on the bus. And we know that that's 29. If that's 29, how can we continue? We know that all that is 105. If all that is 105 and that's 29, can we find that? That's not too hard, isn't it? It's just the difference between 105 and 29, which really is 76. If that's 76, how can we continue? This is 29. Can you see more 29s in the 76? That is right. Here's another 29. And that is another 29. So in the 76, we have 2 29s. 2 29s, that's just 58, isn't it? So if that's 76 and this is 58, can we find the value of 2 units for the adults? That's not too hard, isn't it? And if you know that, can you find 1/5 of the adults? And if you know 1/5 of the adults is equal to 9, can you find out how many adults went on a trip? So that's one of the questions we can answer. That's 5 groups of 9. That's 45. So we can say that there were 45 adults in that group. How about the number of children? Do we know what this represents? Remember, that's 29. And if that's 29, and this is 9, that must be 20. And if that's 20, the number of children, that's right, the number of children would be 60. So that's yet another question we can answer. Are there other questions that we can answer using the information given in the story? Method 3. Some of us know a little bit of algebra and would like to use that to help us. Let the number of adults be A and the number of children be C. We can write that down. And we know that the number of adults together with the number of children, that add up to 105. We also know that 1/5 of the adults and 1/3 of the children, they make up the remaining 29 people who went on the bus. How did I get 1/5 of A? That's because 4/5 of the adults, 4/5 of that number, they went onto the vans. And how did I get 1/3? That's because 2/3 of that number went onto the vans, so 1/3 of that number must be the ones going on the bus. If you're interested or able to solve equations like that, you may continue with method 3. Today is a clever day. We have method 1, where we use guess and check, coupled with making a systematic list to help us figure out that 45 adults and 60 children went on a trip. We also get the same conclusion by using the bar model method and some calculations to go with it. Finally, for some of us who know enough algebra, we also have the method of writing equations and solving them. Dear colleagues, that is one way to present an anchor task. There are many ways to present anchor tasks, but whatever we do, make sure we provide students with the opportunity to learn whatever they need to learn through a single problem. To paraphrase Paulia, it is better for students to solve one problem in 5 ways than to solve 5 different problems. Provide ample opportunities and exploration before structured learning. That's from Dean's theory. Provide concrete materials. Provide visuals, pictorial representations before they move on to abstraction. That is Bruner's CPA approach. Make sure there's ample opportunities for interaction and conversation. That is based on Vygotsky's theory. Also, Piaget's idea of children using their own natural spoken language to grapple with abstract ideas. Focus on conceptual understanding rather than tricks, formula, procedures. That is Scam's theory. In a structured discussion, you would expect the struggling learners to be able to come up with at least one method outlined in method 1. For average learners, they should be able to come up with method 1 and method 2. And if they're advanced learners in the class, method 3 and beyond are some possibilities for them to challenge themselves. In this video, we see how we can implement an anchor task and conduct structured discussion.